Thanks for coming to my video tutorial of solving systems by graphing. While you're here, we're going to review how to solve a system of equations through graphing to find their point of intersection, which is also their solution. So we're going to start with this first problem, and notice that I've used two different colors to define my equations so that when I'm graphing them, I can easily see which color relates to which equation. So we're going to start with the first one in red, y equals 3x minus 4. We always start graphing with our y-intercept, which in this case is down at -4. So I'm going to bring my first point down to -4 on my y-axis. From there, I'm going to use my slope, which is 3. That can also be 3 over 1, which means I'm going to rise 3 and run 1. And each time I rise 3 and run 1, notice I put a point because that is a point on my graph. Once I have enough points on my graph, and I like to do as many as possible, I can go ahead and connect them by using a line and draw your arrows on the ends of that line because they continue in both directions. So now we're going to do our second equation, which is blue, and that is y equals -1/2 x plus 3. So again, we always start at our y-intercept, which in this case is at +3, so I'm going to go up to +3 on the y-axis. And then from there I'm going to use the slope, which is -1/2. That tells me I'm going down 1, and we always run to the right, so run right 2. I'm going to keep going, just as many points as I can fit on there. You could also go in the opposite direction, up 1 and to the left 2, but since we already see that point of intersection there, there's no need to continue plotting points. Go ahead and put some arrows on the end of that line as well. So just a quick reminder here, we always are going to start graphing by using our y-intercept. And then after we use our y-intercept, we're going to go ahead and use our slope to figure out how our line moves. Now, if we look carefully at this graph, we see that there is a point of intersection. That point of intersection is our solution. So on your answer line, you're going to want to write out your solution, which is the point 2, 2. This point is the point that satisfies both of those equations. So if I wanted to check this, I could go ahead and plug 2, 2 into my equation. So let's do that. If I have 2 equals 3 times 2 minus 4, that was our red equation. I'm going to go ahead and solve the math on the right side, and I do get 2 equals 2. So that kind of checks out to let me know that 2, 2 works in the first equation. Now, it should also work in the second equation. So I'm going to go ahead and plug that into my second equation as well. On the right side, I'm going to do what math I can do. So that's going to give me a -1 plus 3. And again, I see that 2 does in fact equal 2. So it checks out for both of them, which means my solution is correct. Let's go ahead and try another one. This one's a little bit harder. Again, I use those two different colors, so let's start with the red. In my red equation, I do not have an x here, which means that my line is no longer going to be diagonal. It's either going to be horizontal or vertical. Because I have a y equals, we can go ahead and remember hoi vux. And in this case, hoi means it's a horizontal line. It's a y equals equation, and it has a 0 slope. So where is y equal to -1 on my graph? That would be right down here at the y-intercept. Y is also -1 at every single point, though, on this line. Right? Again, that's why my line is horizontal, so I can go ahead and connect all of those points on my line, and that is the graph of the equation y equals 1. Now, the blue equation, we have some work to do because it's not in slope-intercept form. So I have to change this into slope-intercept form by getting the y value by itself. First step we want to take to get the y value alone is to add 8 to both sides. So that leaves me with 2y equals a -5x plus 8. And then to continue to get that y by itself, I want to divide each piece by 2. So I get y equals negative 5 over 2x plus 4. Again, when we review our solving systems and graphing our equation, we always want to start with the y-intercept, which is at positive 4. So I'm going to go ahead and place my first point on the y-axis at positive 4. And then the slope tells me how to move. It's a negative 5, so I'm going to go ahead and move my line down 5. And then to the right 2, because we always run right. We can do this again. There's not enough space on my graph. There might be on yours. And then once you have those points, you only need 2 points to connect them to make a line. You should see that they intersect, which again is my solution to this system of equations. So in this case, my solution would be 2, negative 1. And just like we did in that first example, we can go ahead and mentally plug it on into our equations to see if this point does satisfy both of those solutions, which it will. So your answer on your answer line is the point of intersection, which satisfies both solutions, or both equations. All right, guys, thank you so much for coming on to watch the video. If you need more help, you can look at IXL for extra example problems.